Good afternoon, everyone. So for me, it's a pleasure. So it's the first time that I'm facilitating meetup. So it's a pleasure. I think this is the first meetup that we have also in collaboration with Software Crafters Madrid. Is that correct, Elder? I think so, right?
The second one.
The second one. Sorry. So well,
Yeah.
the second one. And yeah, so today we are here to talk about Clojure, which is for me is something really interesting. We also have this, I don't know if it's boom, well, I will say that it's a boom because now we see like many people going towards functional languages, which is really good. So for me, this talk, I'm looking forward to see Mesh talking about that because this is my first time like having contact with Clojure, so I think this is awesome. And yeah, so today we have this this first session. Just remind that this is the first of a series. So the idea today is to have this introduction that Mash will lead the session, and then we have two more, if I'm not mistaken. So we are going to follow up on those about Clojure. And what else? So yeah, we also shared, we expect this to be a really interactive session. Okay, so if you, we see that we have people in the room, so we expect you to follow along. I'll be following along Mash in the session. And I think that's it. I would like to, just to, before pass the words to Mash, I don't know if Elder, you want to say something before we start?
Yeah, usually. So thank you, Codurance. Thank you, Mashooq, to be here. Also, thank you, Valeria, Maria, Matthews, Elena, all the team behind organizing all the events. And the same message as always. Please follow our meetings, follow the groups that we have in Codurance and Software Crafters Madrid, along with the other local meetings that we have. Share with your son, your grandma, your friends, and so on. And we have some interesting things very soon. For example, the Global Day of Code Retreat. I will just say that just as an advertising, and please go there and look at the events that are coming. And that's all.
That's a good one. November the 5th. That's a good one. Good reminder. Thanks for that. And I think that's it. So I think without further ado, so Masha, I will give you the words for you to introduce yourself as well, and then we can.
Okay, thank you. So yes, I'm one of the co-founders of Codurance and a hobbyist developer. I would say I don't get to develop much nowadays. Clojure is my favorite language, and it gives me a lot of pleasure to talk about it whenever I can. Right. So the way that I would like to run this session is very interactive, as Matthias said. I would like you to follow along with me. The session is very basic Clojure. So first of all, I want to try a couple of things. One is if you can use your kind of hands up thing. I don't know how to do that in Zoom, but I'm sure you will. Tell me who has actually used Clojure before. So hands up, everybody who's used Clojure before, even if it's the smallest bit. Elder has. Tim. Okay, not sure.
Just one thing, if you don't know where the hands up is in the right in the bottom. We see reactions. I think it depends on if you're on Mac or Linux. I don't know, but you have the reactions, and then if you click, you can like raise
hands. Perfect. Okay, so a few people did raise their hands, and they said they have used it before. So I'm going to apologize to you in advance because you might find this very basic. The problem is that if I start with any kind of intermediate of a higher up role level, then I will lose people. So the idea is to stay very, very basic, stay very close to the ground, as it were, to introduce you to the language, to introduce you to some of its constructs. And we will even do a little exercise. So if you find it boring, then just bear in mind that we're pitching it at a very basic level. And for you, it might even be interesting. So bear along anyway and keep your mind open. Yeah. All right. Okay. So the other part to this is that while everyone is following along, what I would like to do is, if you are stuck, then tell us. Yeah. So you can basically unmute yourself and say, I am stuck. I will then ask you to share your screen. So we've opened up screen share for everybody in this Zoom session. I will ask you to share your screen, and then you can show us where you are stuck and we'll get you unstuck. Yeah. It doesn't matter how far we go into this session. What matters is that you follow along. Also, in the process of getting you unstuck, other people are watching this and they will learn more, right? So don't feel bad. Actually, it's a deliberate mechanism to teach people the things, because we learn from our mistakes. Yeah. So with those two things, don't be shy, raise your hand or just shout, say I'm stuck, and we will share. I will stop sharing my screen, we'll share your screen, and we'll see where you are stuck. Yeah. Okay. So first of all, let me share my screen. And I bet you some people will say that they are stuck at the very beginning. All right. So, so can you see my screen? Yeah. And you can read what's there? Cool.
Yes.
All right. So, thank you. If somebody is, can you please let me know if somebody is raising their hand or saying something, because I won't be seeing the chat side of things. So just let me know. Yeah. Okay. So the first thing is, I had asked you to install Clojure tools. If you haven't installed it, there is still time. You can, if you can just share the link again on here. And also, there is a link to REPL, and there's another link to try Clojure, and they're web-based kind of REPLs that you can use to follow along. Yeah. So you'll see Matthias, if you could share those again, if people haven't seen them. Thank you.
The repo, try Clojure, both of them. We have other already shared, so we have both.
Okay, perfect.
There you go.
All right. So if you are stuck in installing Clojure on your machine, just just use one of those links, and you'll be on our website, and you'll be able to follow along with the exercises. Yeah. All right. So the first thing is the Clojure REPL. Oh, by the way, before you even start the REPL, one thing I would like you to do is create a directory called, like I have, so called, Software Madrid or something else, whatever you want to call it. And within it, I have a couple of files. Don't worry about the task.md. That's for me to see what I'm going to do today. But create a file, empty file called ex1.clj. Yeah. That's just almost like a workbook for you, because the REPL is not a very good editor. And so you can use a text editor. Don't worry about an IDE. We are purposefully not using an integrated development environment, because we want to learn the language itself, and not an IDE. It brings complexity. Okay, so have a text editor, even if it's Notepad or so on. My favorite is Vim, so I'm going to be using Vim, but you can use whatever you like. And see at the bottom here, I have mine empty, and then a list of things that I need to tell you about. And then on the right here, I have the window for where I will start the REPL. And the way you start the Clojure REPL is by CLJ, right? So if you type that, it will say, I'm using the latest version of Clojure, and it started the REPL. Yeah, you're all following along? Okay, cool. So today, what I will try to teach you is what the REPL is, REPL. I will teach you scalar data types, what equalities kind of means, because I think it's important. Clojure is homoiconic, so I'll tell you what that means, because it's important. Clojure is based on the Java, the JVM. So it actually can access anything within the JVM, any Java library, any of your own Java programs. That makes it actually very powerful. I'll tell you something about native data structures, primarily lists and maybe vectors. I'll tell you about conditionals, and I will tell you about functions. And all those things can help us then we'll do a bit of mock programming session where you will show me how to write a FizzBuzz program. Yeah. Okay. So at that point, if we have time, I will ask everyone to open up their mics and shout at me on how to write the FizzBuzz program. Yeah. Okay.
Yeah, sounds good. Mash, just before you proceed on this one, we have two questions. I think it's related with what you're saying, like intro.
Mm-hmm.
So the first one is Clojure a duck type language? Do you want to answer that now, or you're going to?
What language?
Clojure is a duck type language.
Duck type. Ah, interesting.
Duck type. Yeah.
It's a dynamic language, and duck typing is, yeah, if it's if it fits, then if it walks like a duck and quacks like a duck, it's a duck. That's the kind of language used for Ruby, because there you have objects. In Clojure you don't have objects, right? So it's not that relevant, but Clojure is a dynamic language. Yes, like Ruby, like other languages that might have duck typing, Clojure is a dynamic language. It's not strongly typed. What's the other question?
The other one is lane REPL. Lane REPL, I think that's how it says. Same as CLJ.
Yes, it is. The REPL is the same. CLJ and leiningen or line. They both basically build tools, and they start the REPL, but the REPL itself is the same. So once it starts, it's the same. So if you're using leiningen, and you can use line REPL, and that will do the same. It will bring you to this command prompt. Yeah, it might give you a bit more information at the top, but the command prompt and the REPL is exactly the same. Okay. So what REPL means is read, evaluate, print, and loop. That's what it stands for. It's basically a small environment where you can write a Clojure expression, and then it will evaluate it for you. It will run it for you, right? That's what a REPL means. Basically, it's a fancy word for that. So the other thing is that why am I not describing Clojure to you in detail before we are jumping straight in? And the reason being, if you ever get a chance to read a book called Mastery, there's a lot of research in. If I say things to you, you won't even understand them. You may even understand, but you will not be able to place them in context. So the idea is that I get you started with it. You kind of play with it almost like a toy, and then in the next session, if you can make the next session, we will talk more about the language itself and its constructs and its philosophy and its paradigm, right? So at the moment, we're not going to even talk about those kind of things, yeah, because right now it doesn't matter. We are just going to play with the language, yeah. All right. So as I described to you, that's a REPL. So let's say I want to add two numbers. Oh no, forget even that. Like, let's do the first thing first, right? So let's print hello world, right? So print. So you start with a bracket. Clojure is all about brackets, right? And I'll tell you its significance later on, right? So you print ln hello world, yeah. Enter, and it should print hello world and nil, yeah. So let's deconstruct this. There is the start of the bracket, the name of the function that you are going to call, which is called println, and then everything else is a list of arguments separated by a space. So this is a string or hello world, so it's a single argument, even though there's a space here, but this is a string. So that's one argument. And then once you've done with your list of arguments, you put a close bracket, so close parenthesis, and that's it. And so it will run that function and it will give you its result. Now, everything is an expression in Clojure. There are no statements like like languages like Java, for example. You have functions that have void return, so they return nothing. In Clojure, that's not a concept. Every expression or function, so expression is calling of a function, yeah? So every expression returns something. Println returns nil, right? But it returns something. Because this particular function has a side effect, means that it puts something out to the console. So it's not returning hello world that you see, that it's printed, and then it's giving you nil as the result of that function back. Yeah. So that's right. And so, for example, if I add some more, like this, it will print hello world and you, and then say that println actually returns nil. Yeah. Everyone following along so far? So that's our hello world program.
Yeah, I'm following you along. Okay, so we had a question in the chat, but you already answered that. Like if it's what you're saying is a function expression or a function declaration. So I think
it's a function. It's not a declaration. We're not declaring any functions at the moment. I will tell you that if you look at the left in my line 15, I'll teach you how to write a function. Yeah, but at the moment we're using the function that already exists. So println is a function that already exists. So this is a good segue into talking a bit more about what kind of things that the REPL can give you. Yeah. So the REPL has a few commands, like the doc command, that tells you that you can use to ask a bit more about the function. Yeah. So I've said doc println, and it says it's a same as print followed by a new line. So I can say doc print. It tells me prints the object to the output stream that is the current value of the out, right? So it prints the console basically. So you have this way of finding more about the built-in libraries and functions of Clojure. Yeah. You can also, if you want, you can use find doc. And that would, if I say find doc print ln, it will, in fact, that takes a string. So it takes a string or a pattern, but I won't go down that route for now. And you can find all the functions that are currently available that are related to println. Yeah. So this also allows you to explore some of the functionality that's available to you within Clojure. Yeah. So the other thing that you can do is there's like *1 actually gives you the results of the, so it gives you the results of the previous command run, but you'll find that it's better way, and then you can use it in something else. So it's a handy way of referring to the results of something else that you may have run into, and you can do *1, *2, and *3. So that's also a thing that the REPL has. Yeah, that's about it. So Clojure REPL. Oh, there is one other thing. You can use source print ln, and it will give me the source for that, the source code for that program function, right? So you can see here defn println, same as print followed by new line. That's a comment, and it says, and then it creates a binding and so on. But don't worry about those things. But basically, it gives you the source code of the function as well. So that's another thing that you have available. It helps, for example, when you're running your own code and you've got things defined and you want to quickly find out what happened in there, and you can play along in the REPL. Yeah, cool. So let's go to the data types. One of the functions available, I can say doc class, because it's Java. Class function tells you returns the class of X. Yes, so whatever I give it, it'll give me what the Java class is. So this is a good way of exploring what's under the hood within Clojure. Yeah. So for example, I can say doc 1. 1 is a number. Sorry, not doc, class 1. 1 is a number, and it tells me that's a Java long, right? So Clojure always uses longs. You can force it to use something else, but it's always using longs. It doesn't use integers. Yeah. So the other thing is I can look at class. I can give it my string. What class is that? Well, it's a Java lang string. So again, you can see under the hood what it's doing. So when it has all the data types that you have in Java, in the JVM, and any other language really, you can use them. It has floats, for example. So I can say class 2.0. Yeah. Well, that's a double. Yeah. It won't use the float because double, it has a larger precision. It will use a double. Yeah. There are other kind of numbers in Clojure that you don't get in many other languages. So it has rational numbers, for example, right? So you can say one, so you can say half. In Clojure, you can say a half, right? So you don't have to say 0.5, that's a decimal. This is a rational number, it's a fraction. See, it's a ratio, right? So you can, so then what you can do is you can now start thinking about, okay, well, actually, before I even go to what you can do with the data types, I can also show you some other basic types. You have characters. So this is a character. Yeah. You have regular expressions, which are built into Clojure. So that's how you provide a regular expression. So you can say, I don't know, hello, stuff like that. That's a regular expression pattern. Yeah. You can also have keywords in Clojure. So in Clojure, you can say class, and I'll tell you what keywords are. So keywords are like best used as keys, or it evaluates to itself. It's a much more efficient mechanism for having keys to values than strings. So in Java, C# and those languages, you often use strings as the key to, let's say you're using a map or a hash map or something. You'll use these key value pairs and the keys are often strings. Well, strings are actually not as good as evaluating to themselves, whereas a keyword evaluates to itself much better. So it's a very fast way of creating keys. It's also good for enumerations and all those kind of things. Yeah. You also have symbols. Symbols is basically something that is bound to another thing. So a symbol can be, I'm going to bind a variable X to a value. So X is a symbol, right? So you can create symbols like this. I can like this. So basically these are the different kind of data types that you get in Clojure. Following along so far?
Yeah, and I think we have another question. I don't know if, well, I will ask and then you see if it fits in here or later on
Sure.
in the talk. Motadi, I think is how to pronounce his name, asked, do we have lexical scope in Clojure? And also nested scopes, I think it's also known as nested scopes.
Do we have scopes? Yes, we do. The Clojure has namespaces. So anything is within, in fact, I am in the user namespace at the moment. Yeah. So you can actually go into any namespace and then refer to it from that namespace. But that's a bit advanced topic, so I wouldn't go into it at the moment. It also has function scope. So anything defined within the function has function scope. It also has let blocks and so on. Again, I will describe those in a later time. But one thing that I will show you just now, which is the next part, is Clojure is mostly immutable. It does not, the way it's designed is not by changing state. That's why it has expressions and not state. It does have a statement, but it's not really a statement. It's also an expression. It's actually a macro disguised as a statement, but it does not, like, one of the things that you might be thinking is, how do I describe a variable and how do I then change it and how do I put it in an object, and those, forget about it. Clojure is not an object-oriented language, right? It treats data and functions separately. It doesn't put the data and the functions together. And the reason you can still have a good level of encapsulation is because all data by default is immutable in Clojure. When you change a list, when you add to a list or remove from a list, you get a new list. You don't get the same list, right? So everything is immutable by default in Clojure. Yeah. So this actually completely changes the way you program because you return stuff. So your style of programming becomes a declarative and not imperative, right? So you creating expressions that are nesting other expressions and so on in order to achieve results. And that is the functional way of working. But I will talk about this later on because again, we are going into very advanced topics and let's come back to the basics first. Any other questions?
Yes, we do have one from Elder. I don't know, but I think he asked if the parentheses are redundant. I understood the question like that. I don't know if
yeah, no, let me clarify. Is because we are using over and over again parentheses for things like, okay, give me the documentation for this function or print this line or so on. So it kind of smell like redundant, but I'm feeling that it's not because maybe we can use those parentheses for something else, but I can wait. No problem.
Yeah, the parentheses are not redundant. Actually, Clojure, one of the reasons Lisp as a dialect is very, very powerful is that it works slightly below the C style languages, is that you are writing an abstract syntax tree. And you have, it has no notion of, like if you really think about even the C style languages, they have a lot of brackets. It's just that we've learned to ignore them, right? Like if you think about it, calling a function in Java or C#, it has two brackets. They're just after the name of the function. Clojure has those two brackets. They're the same number of brackets. In fact, then in Java, you may even get curly brackets right after that function. Clojure doesn't have that. So the bracket thing is a bit of a misnomer, but yes, they are needed to answer your question. And once you become proficient in programming Clojure, you start realizing how powerful they are when it comes to editing, because you edit in blocks. You edit as abstract syntax tree and not characters. And actually editing becomes very much faster for that result. But again, quite an advanced topic. So coming back to the equality. So you can obviously these numbers that I gave you, you can start doing things to them. Add 1 and 1 is 2. This is the other thing. Clojure has a prefix format, not a suffix, not an infix. What does that mean? That the operator comes first and then the operands. Again, people think, oh, that's nasty, because you have 1 + 1 = 2. Well, actually, it's consistent because everything is a function, plus, minus, they're all functions. Even in Java and C#, they are functions. So why are plus and minuses and so on treated differently to the method calls in other languages? Clojure keeps that consistency. It says, well, everything is a function, so I'm going to treat it like a function. So that's why in everything, the way it works is you get a bracket, and then the first thing is the name of that function, and the rest are arguments. Yeah, that's how Clojure works. So it actually is quite powerful because what it does is it gives you a bit more power in terms of how you use that function, right? It's more concise because actually, if we were to do 1 + 1 + 1 + 1 + and so on in another language, you will have a lot more redundant pluses, right? So again, it actually creates this conciseness in the language. So you can do many things, the times and so on, and they all work in a similar way. Yeah. There are some other functions as well that you can use on the functions, but I won't go into too much at the moment. There is the equalities function as well. So equals 1 = 1, which is true. Yeah. 1 does not equal 1.0. That's false. But if you want that, then you can say double equals. That is a fuzzy equality. And that will return the true. Yeah. So, and things, equalities are deep. So they're based on value. Yeah. So I can have, and I will tell you about lists later. So for now, just think that it's actually a vector, but let's say 1, 2, 3, 4. 1, 2, 3, 4. Do you think that will be true or false?
True.
Yes, it will be true because the values are the same. In Java and other languages, the equalities are by reference. If you want to do this kind of equality, you have to do dot equals and you have to kind of enumerate and then do equals on the scalars. Clojure can do equalities on the data structure themselves. Yeah. Okay. So that's, I mean, you can also, but there are other ways of, but I think this is the basics of equality, and it's enough for now. But there are other aspects to this, but we won't go in there. Okay. Okay, so far? With me? No one's lost? Good, good.
No questions, so I think we're good to go.
Alrighty, cool.
Yes.
So then what we are going to do is, I'm just going to bring this up a bit. Okay. So the next thing I'm going to teach you is the power of Clojure, which is homoiconicity, right? And this will help you answer some of the questions about Clojure's parentheses, right? Clojure is a Lisp dialect, and Lisp stands for Lisp processing languages, yeah? Because the code and data in Clojure are treated the same, right? And that makes the language very, very powerful, right? The way that you create a list in Clojure is you can either say, okay, you can escape. So 1, 2, 3, 4. The other thing was a vector, by the way. This is a list. Yeah. A list is a number of items within parentheses is a list. It's a data structure. The only thing is the Clojure REPL and Clojure programs, if you don't escape the list, it automatically thinks that you're making a function call. It treats a list as an expression. So what it does is it will try to, if I don't escape it, this is actually a list. But if I just put it there, it says error because it can't, it says that long, which is 1, is not a function, right? Of course, it's not a function. What Clojure does is by default, if you give it a list, it tries to execute that list because to it, data and code is the same thing. Now, this is very important. That's why it's a homoiconic language. It's the only one. And that's where its power in data processing comes. Now, in order for me to tell it, actually, no, don't worry about executing this. It's not an expression. I do this and it says, oh, okay, it's a list. Yeah, right. So this is basically a list. Like in Java, it's an array list or, array or a collection and so on. In C#, they're called similar things. And other languages, they'll be called the same kind of thing. Yeah. So this is important. Now, let me show you something kind of magical. If I say plus 1 and 1, like 1 and 2, maybe, yeah, that's you. If I do that, it will just tell me plus 1 and 2, right? But now I can take that plus 1 and 2 and my REPL is okay. I can take this and I can say evaluate this list. I will evaluate to 3. Right? So I'm taking data and I'm telling Clojure, oh, by the way, it's actually code executed. So this then makes the language extension very, very powerful in Clojure. That's where macros come from. Again, we'll talk about them at another time. But in Clojure, the base of language is very, very small. Everything else, when you look at libraries and so on, are macros. And macros can be very powerful indeed. And when I describe macros to you later on, I'll show you how you can create domain-specific languages, DSLs, that are super expressive in Clojure because of this ability. Yeah. Okay. Have I lost you yet?
One quick question, Mesh, that we have. It seems like some. How can you exit the REPL? Because some people say like is Control D or if you
Yeah,
write
Control D or
parentheses.
Control C will exit the REPL. Yeah. Like that.
Okay. But yeah, okay. So just to clarify that thing for people. So that's good.
Okay.
I have we have I think Elder. Elder, you want to ask something about security?
No, it makes me remember the val executor on JavaScript, so makes me the creeps, but it's something for the future. So.
Cool. All right. So yes, you can execute JavaScript in JavaScript that has been streamed in, yes. And you can do the same in Clojure. But yes, a powerful tool is a powerful tool. You can damage yourself or do something great with it. That's up to you, right? Cool. So next thing, Java interrupt. So as I mentioned to you, Clojure runs on Java, and you can call almost everything in the JVM ecosystem. You can call it from Clojure. And in fact, you can do it the other way around as well, but I won't go into it. So for example, if I wanted to do println like hello world again, but in the Java way, in Java, you would do like system.out.println, and then the string hello world. Yeah. So in Java, it will look like something like this. Yeah. Right. Of course, this won't run here, but you can actually run this command. I'm just gonna change that to, so the way you invoke a function is the dot notation within, so a JavaScript method, sorry, a Java method with the dot. So I can say println like this, and then I say system is the class, and it's actually being used as a namespace because out is a static variable of. So when you're using namespaces, if with Java, you use the /, and then I can say hello world. So this will actually call the Java method hello world println on the system out. Yeah. So you can do almost anything that you can do in a Java program, you can do with Clojure as well. So you can use Java libraries, for example, that may not exist for Clojure, although Clojure has a very strong ecosystem of libraries. The other thing is that Clojure also has exception handling, which actually is a side effect and not common in a functional style. It's actually not a functional style, but Clojure is very practical. And it's like, if you compare it to Haskell, Haskell is very idealistic. And that's why people find writing, commercial software difficult with it. Clojure is designed to be practical. It's not designed to have ideals. It's designed to, it says, well, okay, you on top of the Java ecosystem uses exceptions a lot. Well, you should have a way to deal with exceptions. So Clojure, you can deal with exceptions. I think what you can do is say try, if I can remember this correctly. So then I can throw, and this is the way to invoke a constructor. So that's a constructor. It's almost like saying new exception, hello. Yeah. So I'm throwing this new exception, and then I can catch. And then I can catch this exception. So in this case, it will be, sorry, my machine is very slow for some reason because of what I'm, okay. So if I exception E, and then I can call something on this E. So I can say dot get message on E. On E, yeah. And that I've caught this exception, and I'll stop the try as well. and this should run. Yeah, there you go. So it said, so it's getting that message on the hello. So it's created the exception, thrown it, and I've caught it, and I'm printing its message. Yeah. If you are struggling with these parentheses, I can put it in here. Yeah. And I can show you how it actually in Java, where you can probably see it like this. Yeah. Yeah.
Yeah, I'm trying to follow, but it seems like I'm not. The parentheses is not helping me out. Let me see. Try.
Yeah. So that's why I put it in an editor, and you got a throw, and then you got exception, which has its own parentheses, and then you have. Yeah. So as you can see, my visual environment is set up so the parentheses are rainbow parentheses, so they color match, which makes it easy. And also Vim shows you when you start with one where to end with. Most IDEs do the same, yeah. But you can then, if I can then copy all that into here again, like this, copy and paste it like that, it will do the same, yeah. So you can copy paste stuff from your editor if you're struggling into the REPL, because REPL is not the nicest way to edit. Yeah. Okay, so that's how you can handle exceptions as well. If you're kind of struggling, you can skip this part, because yeah, you get the idea. You can throw exceptions and catch them in Clojure, just like in Java. And if you're doing a lot of other, there is another notation for calling things. We call dot notation. I won't go into it in detail, to be honest, because yeah, you don't have to do a lot of Java intro, but safe to say that all this kind of method chaining and so on that you saw here in brackets, that could cause lack of clarity, and there are ways of making that better. Yeah. Okay. And I will show you Clojure has some other mechanisms of making it look nicer and better, right? So next thing is the native data structures, and I started with the list. Yeah. So let's start it. Def X. So this is how you create a var, a variable, but it's not really a variable in the strict sense of the word. It is very dangerous, and it should not be used to maintain state. Yeah, it's basically a binding. It's nothing else. So if you use that to maintain state, it's like maintaining static global state in Java or C#. So don't do it, right? But if you want a constant something that you keep but you don't change that much, or you use it to wrap, which I will describe later, an atom, then you can use it. Or you know how to use dynamic variables, which are thread bound. So when you create them, they have thread scope, then you can use it. But don't use it as they are, only for constants, so some constant value that you read and you're never going to change. Yeah. I'm going to describe to you. So defx, let's say in this case, because we are playing, you can use it. So defx 1, 2, 3, 4, 5. So this is my list, and I'm saying take this list and assign it to X. Yeah. So if I say X, it will tell me that that's the list. Yeah. So now I can do things on that list. I can say, what is the first in X? Is 1, and I can even say what's the last in X. Yeah. I can even say what's the nth in X. So I think it's X is 3. Yeah. So again, it's indexed from 0. These are akin to linked lists, by the way. They're not indexed. So these kind of data structures, they're not optimized for random accessed. You know, they're optimized for reading and adding to the front or the back, mostly adding to the front, right? Vectors are better if you're going to add, insert, and add to the bottom or the front. They're better, but I'll tell you what vectors are as well. You can also say rest of X, and that will give you. So again, the first and the rest actually help with recursion and those kind of things when you go in over list. Yeah, so they're quite good to use. I will tell you about the other things later because they use higher order functions like filter, map, reduce, pop. Pop and peek are actually fine. You can say pop from X. So what it does is it takes away the first thing and gives you the rest of X, because X is 1, 2, 3, 4, 5. Yeah, you can say peek of X, and that gives you the first element. X is still the same. The data is immutable. What you get back is doesn't change what X is. Yeah. So you can do whatever you like to X, but you won't change the value of X, right? So that's what immutability means. You can't change them. Clojure is super fast at, you know, you might think, okay, well, every time I add a remove, am I like creating lots of copies and so on? You're not. Clojure has hierarchical data structures, and they are faster than Java's own data structures and more memory efficient as well. So you don't need to worry about it. Okay, vectors are similar to lists, but they are indexed. Yeah, so you have like vectors are described as in like this, and they are indexed, right? So sorry, so you can in vector, I think you can do stuff like get to a particular element, but they are much more efficient. When you did nth in, so you can do stuff like nth x y, but it's much quicker because in lists it will traverse the list. You get to the point where it will find the element, second element, third element, and give you that. With vector, they are actually an index list. Yeah. So you will be able to, it's much faster. So if you're doing kind of index type, you know, access and so on, use vectors, otherwise use lists. I won't go into, there is a thing around cons and conj. If you do a doc on cons, it returns a new sequence where X is the first element and sequence is the rest. Yeah. So so you can, for example, if I do X there, and if I do cons X, yeah, sorry, an element, so let's say 6, yeah, to X, I get a list where 6 is added at the first place, yeah. But if I do the same thing to y, which was the vector, you see it's added it to the end. No, it's added it to the front as well. I think the two, yeah, they work the same. So it's added it to the front. Conj, on the other hand, works, from what I remember, differently. So that takes a collection and adds an element to it, right? So if I do conj, so again, X is this, Y is that, yeah? If I do conj to X, let's say 6, yeah, it will add it to the beginning. But if I conj to Y, it should add it to the end. Yeah, so you got 2 6s at the end. Because a vector is optimized to add to the end, and a list is optimized to add to the beginning. Yeah, because that's the way the data structures are designed. So again, it's good to understand how the data structure is designed and kind of usage that you're going to make it helps you create much faster programs. Cool. So have I lost people here so far?
I don't think so. We just have one question from Herman that asks, can you mix a string and numbers on a list / array?
Yeah, you can. I mean, you may have certain reasons because, like, for example, if you have tuples, right? If I have a tuple is basically a set of values that are not the same. Yeah, it doesn't have to be the same, but the related values. You know, if I wanted to say tuple 1 is 1, yeah. Right. So this is a vector, yeah. So it is, and you can have these values, of course, and again, they are actually tuples work they are very powerful mechanisms, especially when you're returning things, when you addressing values that are related to each other and those kind of things. In Java, C#, so on, you know, you have to create a value object, right, for these kind of things. But so in Clojure, you can just do that and create tuples, and they can then be an element in another list, right? So its flexibility allows you to create complex data structures. Any other questions? No. Alrighty.
So far, so good. Yeah.
No? Okay.
No.
Thank you. Right. So let's move to conditionals. Right. So how do conditionals work? And so again, as I said, everything is an expression. There are no statements. In all languages, particularly if and so on, they are statements. They don't return anything. Because, you know, we work with side effects in those languages. That's how they're used. Clojure is not used like that. So your conditionals return something. So the if is an expression. So if you do doc if, see, special form evaluates test. If not, the singular value nil or false, right? So if you see how it's created, it's a form that takes a test, its value, true, then returns the first, and the false returns the second. This is how I described it here, but it's single value nil or false. Evaluates and yields, then otherwise evaluates and yields else, right? So you can see that it takes 3 forms: the if, which is the call, the test itself, the then, and the else, which is optional. Yeah. So let me describe that to you better, right? If 1 equals 1, then say return hello, otherwise return world. Yeah, that will of course return hello. And if I say if 1 equals 2, which is not true, it will return world. Yeah, so that's how it works. As you can see, it's an expression. It's returning something. It's returning a result. Yeah, if you want some kind of a side effect, you can do an if do, right? So you can say if, in this case, I'm just going to say true. Yeah, and you want to return something, but you want to do something as well. So you can say do, and you can say println done it, and then I'm gonna return hello back. Yeah, so see, it's printed out, done it, and it's returning hello. Yeah, so you can change things if you got a side effect within it. Normally, if you don't have side effects, things look much nicer because you don't like the way your expressions are created, they are single lines. They're not like do this and this and this and this, blah, blah, because that basically means you've got side effects or not single responsibility going on. But anyway, that's a much more of a philosophical discussion. So, so you got if do's, and then you've got case, which again, if you do doc case, so you've got clauses. So you basically, you can say like a case clause, the way it works is case X, yeah. So the X is the test, yeah. So, but in this case, it's always based on values, yeah. So it's been a while since I wrote a case statement, but the way you would do that is it's kind of pairs of values, right? So like I can say the value would be, let's say I say def X is, in this case, I'm going to rewrite it to 1, yeah. Then I can say case X, in case it's 1, I can even do like this, right? In case of 1, say hello. In case of 2, say 12. And then I can have a default case as well. Don't, yeah. So in this case, it's printed out, see, it's returned hello because X is 1. If I say def X is 3, I'm changing X, and then I run that. Kind of, I'll have to redo the whole thing. That's why REPLs are very bad to coding, but that's fine. So, yeah, because now X is 3. Okay, makes sense? So that's how a case works. The only problem with case is it doesn't allow you to put an expression for each thing. It has to be value. It's like the switch statement in Java or C# or other languages. But you can there is another conditional operator which is much more powerful, called cond. And what that does is basically it's a bunch of clauses and their values, right? So it's a test and expression pairs basically. So you can say con. So in my case, for example, X is now 3, yeah? So I can say con X equals 3. In that case, return the statement hello. And I can even say if X, sorry, so you will have to say, do this, right? X is 3, yeah. Condition X is 3, and I can say, well, return hello. Okay. I can also then say, well, some other condition, or equals Y is 5, yeah. Return world. Like that, yeah. So in this case, it should return hello because X is 3. So as you can say, it's more powerful than case, but more complicated as well. But for each test case, it allows you to have an expression that it will evaluate. Yeah. So it doesn't work on just values like case does. Yeah. So those are the conditionals that you have. Any questions?
Yeah, I do have one question. How can we comment in Clojure?
Yes, you can comment in Clojure. There are 2 forms to comment. I think you can do this. That's a comment. Yeah. And also you can say comment. That's also a comment. Yeah. So yes, you can have comments with the semicolon at the start. Any other questions?
We had some discussions in the chat. I think it was already answered, but Miguel asked if what the conj function, what it returns is a list.
Yes, it returns a new list, not the same one that it took, but a new list with the thing joined to add it to the data structure, depending on what data structure that is. Yeah. This is another thing that you'll find in Clojure. It's very self-similar. You know, things you can do to one kind of data structure, you can do to the other. You can use the same functions to do both. They kind of interchange, and it just relies on what kind of data structure it is to decide what's the best thing to do with it.
Okay, that's it. We have another question, but I don't think that's related. He also asked if it's a protocol, right? So I don't know what Miguel meant by protocol. I think
protocols are how Clojure does interfaces, but it's a very advanced topic.
Advanced topic. Okay. So Motazi also asked, Clojure can manage async operations, but I think this is an advanced topic as well.
Yeah, it's a very advanced topic, but yes, very easily. It has built-in functionality called channels, and it will allow you to do async operations in a very elegant way. Yeah.
That's it. No more questions.
All right. Cool. So functions, finally. So the way to write a function in Clojure is using, you can write it in many ways, but I'll just use the basic way. Functions, you know, there's a macro called defn. It defines a function with the name. So you can say hello. That takes a bunch of arguments. In this case, we're not going to take any arguments, and it will return something. But in this case, in our case, we are actually creating a side effect, println hello world. So so as I define it, oops, println in this. Oh yes, typo. Okay, so see, it's created a function in the username field called say hello. Yeah. Now you can call that function. So you just put it in parentheses, and that basically means, yeah. So hello world is what is printed to the console, and nil is what it returned, because println returns nil. So it's the final expression that is the return. Yeah. So that's how you create functions, and you can also say defn say name, and you can say, okay, whatever my name is, and you can say println hello name. Yeah. Okay. So now I can say name. It'll say hello. Yeah. So basically that's how arguments work within. The real function is the fn, because actually what that say name is doing is saying def. Remember, we use def x, right? So we can say def say name. Let's say 2, so it doesn't confuse you. But, so that's the symbol that, and then I'm saying it's a function that has a variable n, and then it's saying println hello n. These and the one above, they're both equivalent. Yeah. So as you get, the reason that I'm showing you this is that what you got is an anonymous function. Fn is an anonymous function, but I bound it to a variable called, or a symbol called say name too. Yeah. And that's what defn does. It's just a macro. In fact, if I do I've never done this, macro expand. Defn. Yeah, I don't know the syntax for macro expand, to be honest. So, but I can describe that to you later anyway. But it's defn is a macro. If I do doc macro expand, yeah, it takes a fully called form. So I can say I'm just try one more time. Macro expand def and say I'll have to okay, see. Yeah, let's see.
I think there is a typo. It's not
Pardon?
expand. I think there is missing a D.
Oh yeah,
Expand.
yeah. So I'm just gonna do some, yeah, so that would be a macro and then it's the def and say, it's quite an advanced topic, but it's more for my own curiosity than yours now. So say hello and just gonna return and still, yeah, there you go. See, as you can see, the def and macro say hello n actually evaluates to def say hello fn n of n, just like I showed you before. Yeah, so def n is just a macro that is then used to do what I showed you under the hood, right? But again, don't worry about this thing. I will describe macros to you a bit later. All right, so finally, this is the time when we got to do, we've got about 23 minutes left, 20 minutes.
Yeah, we got 22 minutes. Well, it depends if you want to leave room people to ask questions. 10 minutes for questions. We have 12 minutes.
Oh, they've been asking questions already, right?
So yeah, so we have that.
Okay.
22 minutes.
I'll try to give you some time, but okay. So basically, what we're gonna do is, do you know the FizzBuzz in kata, right? So what does FizzBuzz do is basically the way that FizzBuzz works is that you take, like, if I want to call something a function FizzBuzz, yeah. Yeah. And if I give it a list of 1, 2, 3, 4, 5, 6, let's say, yeah. Okay, so if I do that, then the returns should be, it should return to me is 1, 2, fizz, yeah, 4, buzz, yeah, and 5 will be fizz again. The reason being is that if the number is a multiple of 3, then it's a fizz. So 3 is a multiple of 3, sorry, 4 plus is 5 and 6 is 6. So yeah, so I have to do 6 here as well. Now 6. Yeah. Okay. So if it's a multiple of 3, it's a phase. If it's a multiple of a 5, then it's a buzz. And if it's multiple of both 3 and 5, then it's a fizz buzz, like the number 15. For example, if I put the number 15 here as well, then it should return fizz buzz. Okay. Right. So how would I, so use me as your programmer and tell me how to build this program.
I think that so if just remember, if people wanted to jump, go ahead and people can jump,
Yeah.
right? So we
Yeah.
can talk. I will start. I will just start, but if you have,
You
I
can
will. I don't
start
know.
here.
Yeah, I don't know if I will start the parentheses as
Good
always.
idea.
The
Okay.
def, and then def. That is the name.
Defn
Is
probably describes a good function.
and then FizzBuzz, for example, as you have.
Okay. And then does it take any arguments?
Yes.
Okay, so let's say it takes an argument, which is the list of numbers. So we can call it ends, yeah? And at the moment, we can just say, I'm just going to return ends, yeah? Okay, so I can copy this into my REPL. See, yeah? And so now if I call phase buzz, yeah? And I can give it a list of numbers. Let's say 6 and 15, like we had. So it just returns the numbers. Yeah. So we got a good start. So next thing is we have to loop over those numbers. That's one thing I didn't teach you. But I will show you anyway. So we have to loop over those numbers, right? One way, like in Java, C#, and so on, you know, you think of the for loop immediately, right? Yeah. So we can use the for loop. So let's say, well, how does the for loop look like? Again, it's an expression. So it says, well, it has these sequences and expressions. So you can see here is for X range, Y range, blah, blah, blah. It even has a while, but don't worry. But let's say if I was to do, like, you know, I have X here already, or Y actually defined as that. And if I was to say for, yeah, a number, and the Y is the collection, yeah, and then I can print out the number. See, it prints out all those numbers, doesn't it? I can even say increment that number, so it increments it, yeah. So that's how the for loop works, right? So I can put a for loop in here as well, so that it's not as difficult for you, yeah. So I can say for, in this case, n ends, yeah, and I'm gonna say return n, yeah. This actually does the same thing as the other thing did, because it's looping over and then entering the numbers. I'm gonna redefine FizzBuzz. I'm gonna call it again, and it will give me exactly the same result, yeah, because I'm always returning n, yeah, I'm still returning n, okay. So let's make it a bit easier for you, like this. Okay, now that we are looping over our FizzBuzz, now just here where we're just returning the number, we can do other things, can't we? So who can tell me what to do? So the first rule is that if it's divisible by 3, then I would say fizz. Yeah.
So sorry, Mash, is there any chance you can go through the for loop again? Because you defining the for, then you put in like an I guess it's an argument, the brackets and ns, and I got a little bit lost why we're using n and ns.
Good question. So n, like, you know, like think of it, if you say for I equals 0, which is the, well, forget about the I part, but you know, in you get the for each loop in Java and C#, yeah?
You're defining the variable and then the, let's call it collection that you are iterating.
Exactly, exactly. Oh, it's like your for each loop.
Cool, thank you.
So that's why he's saying, okay, you know, iterate over all elements and assign them to n for each iteration. So now we have n, and that's what we are returning. Because it's an expression, the results of each iteration are then packed into a list and returned to you, right? Because we don't have side effects. That's why every time I return n, it's packed into that list. So now we need to do something here at n, right? So because at the moment the list is, as we get it, is identical. So let's say that we need to put a conditional there to say, well, if it's 3, then divisible by 3. So who's going to tell me what to put there?
Something like if mod n3,
yeah,
and then the string fizz, something like that.
Yeah. So basically what we're saying is this inequality if mod.
Yeah, that's right.
Yeah. So let's say
Mod
if mod exists,
n.
dot mod.
Yeah.
Mod exists. Yeah, modulus of number, it exists. So it takes a number and the divider. So mod n3, thank you. Yeah.
Yeah.
So if 0 equals mod n3, yeah, that's our test, isn't it? Yeah.
Yeah. Then the string.
So in that case, what I'm saying is to return this.
Yeah.
Yeah. Otherwise, just return n. Okay. Okay. So basically what I'm saying here is I'm indenting it for your kind of reasons as well, just so that you've got a good idea. Yeah. In fact, I will indent this as well. Okay. So you got my fizzbuzz is saying, so loop through, and if 0 is, so mod of n and 3 is 0, then return fizz, otherwise return n. Yeah, you think this is going to work? Let's see. So redefine fizzbuzz. Wrong number of args passed to the for loop, right? So we've got something wrong with the for loop, right? So for, it should be a single statement. So for n, I'm going to delete it first. So again, I'm just going to return n for now. Let's see if that's correct. Oops, sorry, my bad. That's why, because I am not. Okay. I was also copying in the line numbers. Okay. For n. Okay, unable to resolve mod. Oh, I put a question mark. That's my bad, because a lot of things that return true or false have a question mark, but mod doesn't return true or false. Okay, so. Okay. All right, so we got a new fizzbuzz. Let's call it. Where was that? Oh, there, yeah. Fizzbuzz passing in those. Oh, there you go. So that works. Yeah. Okay. So now we have to do the other one, which is the buzz. If it's divisible by 5. So what do I do now? So we've done if divisible by this phase, otherwise n. What should I do here now?
We have Herman says, by the way, if you want to give a hint, so you're invited to also to speak in the mic, but Herman says to use count. For example, you can use count to evaluate.
That's pretty
Is that
good.
a good idea? Yeah.
Yeah, maybe. Yeah. Let's say count, because we have this expression test anyway. Yeah. And I think the way with con, you can have an else like this. Let me just do a doc on cons. Clauses, if test has anything. I think maybe I don't even need to provide let's see. Let's see, con equals 0. Yeah, actually, I'll just add this here. So it's con is that, and then the other one is. Okay. So basically, what we're saying is it'd be like this. So otherwise, return n. Yeah, like that. So let's see if this con works still. I keep forgetting that. Okay. Single count. Oh, there you go. Okay. Requires even number of forms. So I think, yes, it is else in here. Okay. Okay. So now if I call that fizzbuzz again, this guy, yeah, so it's still working. So we've refactored it a bit and called use con. So in this case, now it's quite simple because I can now add another one and it say, well, mod of 5, isn't it? And then that would be buzz. Yeah. Now if I call it, hey, I'm getting buzz as well. But it's still not working well, is it? Because actually, if it's divisible by 15, then it should be a fizz buzz, shouldn't it? Yeah. Well, the simple thing would be to just add another 15, and I have to do that first because the other two will otherwise come in first. Yeah. Okay. And now well, hey, we've done it. So that pretty much does what we wanted to do. Now, next time I will show you how to refactor it a bit more to make it more readable. You can see there's some duplication going on there. Maybe we want to extract the rules out into a DSL a bit, that kind of thing, make it look a bit more readable. But that's for another session. Yeah. All right, we managed to do everything. Any questions? We've still got 6 minutes left.
Maybe an initial hint related with the test. I don't know if Clojure comes with any assert by default, something like that.
So as you can see, this is in Clojure. Yeah, it has a built-in testing library, by the way. Yeah, but that is again an advanced topic. But it has a REPL, so you can actually, of course, you don't have the benefit of having this suite of tests that you can then use afterwards. Yeah, but as you can see, I actually created a test and I was executing it at every moment. And in fact, even when we refactored from if to const, without changing behavior, I ran it again. So I was actually doing test-driven development. The only thing is my tests are not written somewhere where I keep them, right? So this is known as REPL-driven development. And I was playing with certain forms. I was showing you how for works. So for example, we tried the for loop and we said, okay, yeah, this is how it works, and we can put it in. And you can, the REPL is actually a very good exploration tool. And it is quite complementary to test-driven development. But yes, you don't have the tests afterwards. So I will show you how to write those tests as well. Any other questions?
I don't think so. I think what would you recommend as a follow-up, after the session? So, better before that, Herman has a better question. Is Clojure used in real life?
Is Clojure used in real life?
Yes.
Very much. There is one of its largest usage is a very large bank that all their systems are Clojure based. It's a Brazilian bank called Nubank. I've seen some very, very large implementations using Clojure. It's in terms of the TIB index, it's like it's still a very niche language. I mean, it's nowhere as popular as, Java, Python, C#, JavaScript. It's nowhere near as popular. But the people that use it, like there's companies in the UK like USwitch and so on. There are consultancies in the UK that are only program in Clojure and nothing else. So yeah, it's used in anger in a lot of places. In fact, two of our clients were Clojure based. MyPulse and a subsidiary of Vodafone. They were all Clojure based. So yes, it's used quite considerably.
I have a question, Mash, if you don't mind. That is, I'm pretty new into this paradigm. I'm really keen on learning about this. And I was learning about different paradigms and so on. And I had the question of, how would you compare the use of this type of functional programming against object-oriented programming? Because in my head, I had that modeling real life things is way easier for me to think in object-oriented programming, and how polymorphism is used in this type of paradigm, because it's quite user-friendly in places like Java, but I don't know in here how it works.
So Java is only user-friendly. Object-oriented programming is only user-friendly because you are native to it. You learned it in the beginning. It is, in fact, there is a lot of philosophical debate on whether it is natural to take the real world and then try to put that into objects and behaviors. Because if you really think about a lot of the applications we write, they're about data and functions on its data. And a lot of and they talk about accidental complexity that arises when you take that data from its original form and change it to meet your abstractions, because data is the most long-lived thing in your problem domain. So if you change your data, so if you look at a lot of Java, C#, these kind of programs, you'll see a lot of data transformations, taking data, parsing, unparsing, putting them into objects, taking them, putting them into SQL, ORM or not ORM. And so there's a lot of data transformation. And these things are actually, it's because the paradigm demands it. And they are called accidental complexity. You have in your problem domain two types, the natural complexity and the accidental. And anything that is not the complexity in the problem domain is accidental. So all data transformations actually qualify as accidental complexity. So again, it's a very philosophical debate, and people argue each side. But as far as modeling problems in a functional paradigm is concerned, I would argue that it's actually easier, just takes some getting used to. And if you are OO native, then yes, it's a paradigm shift, and yes, it has that initial shock to the system.
Thank you.
Okay, so we have a different question. So Motadi asks salaries for Clojure devs.
It's an interesting question. Clojure programmers are the highest paid programmers in the world. Maybe that's why you asked that question.
That's it. I think that's interesting because I think in the last Stack Overflow survey or any survey that is gathered that around, they picked exactly that.
Yeah, they are the highest paid, yes.
The highest. Yeah. Okay, so we have what about a map function instead of for in the fees?
Yeah, map would work much nicer than a for, and I'll show you that next time.
And I think that's it. We don't have any other questions, and I think we are right on time. No, actually, we have, when is the next session for this one? I think it is in 2 weeks. I don't recall exactly, but in the meetup.
Yeah,
just keep
it's
posted.
mid-November, at some
Yeah,
point.
just keep posted in the meetup, so, or the social media as well. So usually we share that data.
I can see if I have it. Yeah, it's 9th of November.
Right.
And there
Okay.
I will be talking more about the functional paradigm and how Clojure fits into that.
Okie dokie then. So I guess that's it. So as always, at least for me, it was a pleasure. So thanks for everyone that joined. Thank Mash for sharing this with us. I don't know. Before passing the word to Maria, like to close the session, Elder, you want to say something, like to finish the session?
Yeah, the same as always. Thank you all for coming. Thank you much for the session. Thank you everybody that is on backstage organizing all this. I put you in the chat the link to the next event, November 9, and take a look because we have another one just in the weekend before. This huge global day of code retrieve cross cities. So take a look. Maybe it's a good opportunity to learn with other people, Clojure and other languages.
You can do the game of life in Clojure. That would be that could be one of the sessions.
Yeah.
You'll finish it in half the time.
So thank you.
Yes, thanks everybody for being here. I also shared a link to the blog where we have all the sessions that are coming up and what are they about, so you can have a look. And thanks again to Helder, to Mateus for being an excellent facilitator, to Mash for this excellent workshop, and hope to see you in the next one.